Good morning, everyone, or good evening, or even good night to everyone. My name is Arifin with my partner Davin, Handreas, Chen. For ISPO 2023 Environmental Science, our topic would be Enhanced Effect of Polyvinyl Chloride Plastic Degradation by Utilizing Bioreactor of Phytoplankton with Pseudomonas fluorescens.
Modern humans now heavily depend on plastic products, as plastics are being used in a wide range of industrial production. And among these plastics, PVC is identified as one of the more hazardous plastics as it releases toxic chlorinated organic chemicals into the water, which disrupts the ocean's ecosystem. So we helped develop a solution. Pseudomonas fluorescens is a bacteria capable of breaking down plastics. However, it cannot finish the process of breakdown in the absence of oxygen. By constructing a bioreactor model, we made a model where Chlorella vulgaris helps to supply oxygen to enable Pseudomonas fluorescens bacteria to digest PVC.
The research problem for our topic is how does Chlorella vulgaris enhance Pseudomonas fluorescens degradation of PVC plastic? And what is the difference in percentage of degradation before and after exposure to Chlorella vulgaris bioreactor? The purpose for our research is to understand the effect of exposing oxygen supplying Chlorella vulgaris bioreactor with the soil bacterium Pseudomonas fluorescens. And the second one would be to calculate the change in average degradation percentage before and after of PVC exposed to Pseudomonas fluorescens connected with oxygen supplying Chlorella vulgaris. So the benefits for our research would be to aid researchers in bioremediation for plastic degradation and helps find effective alternatives to reduce environmental plastic waste and leads to cost reduction in efforts to solve plastic waste issues in waterways.
So this is our stages of researches. First, we measure the mass of 1 centimeter times 1 centimeter PVC squares with an analytical balance, and then we perform the Pseudomonas fluorescens bacterium culture in a nutrient broth under laminar airflow. Then we make the culture of Chlorella vulgaris, and while we prepare all of them, we insert the PVC plastic squares when we perform the culture. After everything is ready, we construct our bioreactor model where oxygen produced by Chlorella vulgaris is able to pass through the tube into the Pseudomonas fluorescens vessel.
For our data analysis technique, the difference in each PVC mass before and after treatment was calculated and the data were compiled into a table. To ensure there is no extreme value present in the data, the standard deviation and mean are to be found by using the formula below. The degradation percentage before and after the procedures are calculated by using the formula below. Then a graph showing the percentage of degradation of each method is constructed. A t-test sample analysis is also performed to find the statistical significance value of two test groups by obtaining the p-value. So the null hypothesis equals to the mean of the Pseudomonas fluorescens only, and then it is equal to the mean of the Pseudomonas fluorescens with Chlorella vulgaris, and the alternate hypothesis is proved by the mean of the Pseudomonas fluorescens less than the mean of the Pseudomonas fluorescens and Chlorella vulgaris. When the p-value is less than the alpha value, which is 0.05, we can reject the null hypothesis and conclude that our research hypothesis is accepted. So after we compile the data, the results are shown. In this collection of data, the average difference in mass and average degradation percentage of PVC plastic performed by each vessels are demonstrated. The degradation of the Pseudomonas fluorescens supported by Chlorella vulgaris is 23.65%, and Pseudomonas fluorescens strain alone is 89.3%. The nutrient broth media is 0%. So after that, we created a bar graph using the data used before. The first bar graph displays average percentage of degradation for 4 groups of vessels with different treatments, and then second, group 1 uses only Pseudomonas fluorescens, and the others use a combination of Pseudomonas fluorescens and Chlorella vulgaris. Third, the average percentage of degradation is shown for each group with an error bar representing the standard deviation. The highest degradation is shown in the second bar and the lowest in the first bar in both samples shown by the 2 graphs. Lastly, limitation of Pseudomonas fluorescens degradation may be due to low oxygen levels. So these are the results from the t-test using Excel that we made. The first data we got is a p-value of 0.004954, and the alpha value is 0.05. Because the p-value is less than the alpha value, the null hypothesis is rejected and alternate hypothesis is accepted.
As an aerobic microbe, Pseudomonas fluorescens is primarily in charge of breaking down complex materials when oxygen is present, where microbiome biomasses CO2 and H2O as the byproducts. Aerobic activities provide substantially more energy than anaerobic processes do because oxygen is one of the most thermodynamically effective electron acceptor for respiration due to its high affinity for electrons. Extracellular and intracellular depolymerases released by Pseudomonas fluorescens cause depolymerization of PVC plastics, which produces shorter carbon chains, allowing them to surpass the semi-permeable outer bacterial membrane, hence allowing bacteria to utilize the broken carbon chains as energy sources. Hydrolases produced by Pseudomonas fluorescens, esterases, lipases, and glutinases can effectively break down ester bonds. There are also some physical property changes present in our bacteria PVC squares. So, to conclude our experiment, Pseudomonas fluorescens vessel enhanced by Chlora vulgaris bioreactor is able to increase plastic degradation activity towards PVC plastics in a higher percentage. By supplying oxygen for Pseudomonas fluorescens to implement aerobic degradation, Pseudomonas fluorescens is provided with more energy to execute deterioration while being able to maintain survivability in a small chamber. Suggestions for future work includes to create a more applicable and realistic environment where both of these microorganisms can collaborate in a natural environment. And another future work might be to place the Pseudomonas fluorescens culture in an orbital shaker for possibly better degradation results. So, to conclude our presentation, we don't need a handful of people doing zero waste perfectly. We need millions of people doing it imperfectly. Thank you.
Thank you, everyone.